Okay, let's dive into this. Humans sit comfortably right at the top of the food chain. And let's be totally honest here. It isn't because of our sheer physical size. I mean, size really doesn't matter when you're the mega nerds of the animal kingdom. We got here using our brains. But that brings up a really fascinating thought experiment. Do brains actually beat brawn? Or rather, what happens when you combine the two? Today in this explainer, we're exploring a pretty wild hypothetical scenario. We want to find out exactly how strong a human being can actually get if we apply incredible, cutting-edge science and, well, absolutely zero moral code. We are going to push past biology, leverage technology, and see exactly where the absolute limit lies. So, to help us safely explore this absolute madness, we're going to need a lab rat. I'd like to introduce you to our hypothetical subject, Kevin. Now, please don't feel bad for Kevin. Kevin is entirely hypothetical, has absolutely no feelings, and conveniently feels zero pain. Which is great news for him, honestly, because we are about to systematically and progressively upgrade him step by step to find the ultimate biological and technological limits of human strength. We are literally throwing everything we have at the sky.
Phase 1, the genetic baseline.
Okay, so we're not starting with just any average guy off the street here. Kevin is a GMO, a genetically modified organism. He was created using the absolute cutting edge in genetic modification technology right from birth. We've perfectly molded his genes to maximize force output. Because of this, he naturally possesses harder bones, much stronger muscles, and significantly faster muscle regeneration than any normal modern human counterpart. It's kind of like he's been on steroids since day one. He's got a massive natural advantage before we even actively start experimenting on him.
Phase 2, chemical enhancements and training.
Because having great genetics is one thing, but come on, what kind of mad scientist would we be if we didn't expose Kevin to a barrage of synthesized hormones? To understand the chemicals we're pumping into Kevin, just take a quick look at this history. In the late 1930s, the first steroid was invented. By the 1960s, countries were literally feeding these compounds to their Olympian athletes like candy, which, eventually led to heavy bans. Fast forward to the modern day, and there is an absolutely huge range of steroids to choose from, with each generation becoming way more potent than the last. And since this is a completely hypothetical explainer, we have access to the full smorgasbord, the whole shebang, including the extremely illegal ones.
Interestingly enough, the very first steroid was actually invented by a German scientist to treat a specific medical condition called hypogonadism, which is basically a testosterone deficiency. Most steroids today are still essentially replicas of testosterone. In Kevin's system, this replica hormone drastically boosts his muscle mass and bone density. Just by giving him this chemical cocktail, he is instantly 20% stronger than he was just seconds ago. Of course, out here in the real world, this comes with a massive, massive physical toll. If Kevin were a real person, he'd be facing difficulty sleeping, permanent nerve damage, severe scarring acne, baldness, liver disease, extreme anxiety, hypertension, and, our personal favorite, the absolute powdering of his bones and ligaments from massive muscle overuse. Yikes. But again, Kevin is our unfeeling hypothetical friend. He doesn't feel pain, so we are just going to comfortably ignore all those pesky side effects and proceed right to the gym. But hey, those steroids aren't going to magically do all the work on their own. Kevin needs to train. And we aren't just doing a casual workout here. We are training purely for raw strength. We send Kevin into our hypothetical gym beyond time for several years. To optimally build strength, he has to lift the absolute maximum heavy weight he can physically handle for just 5 to 8 reps. We are strictly focusing on the big muscle groups, legs, chest, and back, meaning lots of squats, bench presses, and rows. Why? Well, because strength isn't just about muscle size, it's about leverage. Compound exercises teach his entire body to act as a single effective unit to lift more weight. Coupled with a super strict diet of proteins and veggies and plenty of sleep, this multi-year training regime makes Kevin an additional 50% stronger. Phase 3, removing the safety brakes.
Now, what's really interesting about this slide is that even with his GMO traits, massive doses of steroids, and literally years in the gym, there is still a fundamental biological bottleneck holding Kevin back: his own brain. It's truly fascinating how much of ourselves we actually leave on the table. The average person only has access to about 40% of their total muscle potential. That other 60%, it's entirely locked away from your conscious control. This lock exists because of neural inhibitors. These are essentially your body's biological safety mechanisms. They prevent your muscles from using so much force that they literally tear themselves apart or, break your own skeleton. Actually, think about it like this.
It's the reason why when you playfully kick something, you don't accidentally shatter your own shin bone. Even with years of the intense strength training Kevin just went through, that naturally accessible limit only increases from 40% to about 65%. But we actually know for a fact that this locked 60% exists because of a documented phenomenon called hysterical strength. Just look at these crazy real-world examples. In 2006, a mother literally wrestled a 700-pound polar bear to protect her kids and walked away with minor injuries. No way, right? In 2019, a teenager lifted a car off his trapped neighbor. In 1982, a woman in her late 50s lifted a nearly 2-ton car and held it suspended for 5 minutes. And in 2013, a 75-year-old man lifted a Jeep. In extreme emergencies, the brain forcefully bypasses those neural limiters.
Unfortunately, we can't just surgically delete Kevin's neural pathways. I mean, that'd be messy. But we can trick his body. By injecting him with a special override cocktail consisting of adrenaline, cortisol, and endorphins, we can perfectly simulate a life-or-death emergency. This forces his body to drop the inhibitors entirely, finally giving him 100% access to his heavily modified, steroid-pumped muscle capacity.
Phase 4. Technological upgrades.
At this point, Kevin's biology is completely maxed out. He is horrifyingly strong. So strong, in fact, that we actually need to pivot from biology over to technology just to structurally support his terrifying new baseline. The first logical step here is strapping Kevin into an exoskeleton suit. Modern military and construction exoskeletons have the capacity to amplify user strength by a ratio of roughly 20-1, meaning if you carry a 100-pound load, the suit makes it feel like it's only 5 pounds. That is an astronomical gain for Kevin. However, there is a slightly frustrating caveat. Current suit mechanics generally max out with about a 200-pound weight limit. It's a nice bonus, for sure, but we need more.
So, what if he becomes the suit? We could amputate and swap his limbs for advanced prosthetics made of super durable titanium or carbon fiber, carefully calibrated to output massive mechanical power. Actually, scratch that. If we do that, we completely lose his genetically enhanced, organically superior GMO limbs that we've literally spent years upgrading. That's a huge step backward. Instead, we need an internal structural upgrade to keep his biology perfectly intact.
Our solution? Titanium bones. Now, we can't replace all of his skeleton because he desperately needs bone marrow to keep producing red blood cells. However, we can surgically replace his knuckles and softer bones, like the clavicle, with solid titanium. This effectively turns his fists into lethal weapons, immensely increases his overall physical durability, and drastically reduces his risk of injury when he's outputting all that crazy force. And for his final sci-fi upgrade, we're going to introduce medical nanobots. These are microscopic robots injected directly into his bloodstream. While normally used in theoretical medicine to target diseases, we've programmed Kevin's nanobots to rapidly repair muscle fibers. It acts as this profound regenerative superpower. Any micro-tears from training are instantly healed, leading to impossibly accelerated gains.
Phase 5. The final calculation.
All right, it is time to finally tally up the score. But before we do, recall that the baseline, average human, only utilizes about 40% of their natural musculature. Let's see exactly how far we've pushed Kevin. So the crucial point is how all of this beautifully compounds. We start with the average human at 40%. Years of optimal training bumps that to 65%. A massive steroid regimen takes him to 85%. Our adrenaline override cocktail unlocks that hysterical strength, hitting 100%. Adding the exoskeleton boosts him up to 145%. But remember, he's a GMO. That superior genetic baseline adds another 30%, bringing him to 175%. The titanium bone reinforcements give him the structural support to push even harder, taking him to 195%. And finally, the rapid healing of the nanobots rounds him out. Kevin now has access to a staggering 215% strength potential relative to an average man. And this brilliantly illustrates exactly what those percentages look like in the real world. Under optimal conditions, a highly trained average human maxes out their lift capacity at roughly 442 pounds. Our heavily upgraded, genetically modified, chemically enhanced, cybernetic lab rat Kevin, he can optimally lift approximately 1,200 pounds. He is officially 2.6 times stronger than the absolute best average human out there. Which leaves us with a truly profound question. We've just mapped out the theoretical ceiling of human physical capability using tools that for the most part either exist today or are rapidly in development. We know exactly how to break the biological limits. But just because science ultimately allows us to bypass our biological safety brakes and turn ourselves into unstoppable 1,200-pound lifting machines, should we? It's a thought that completely blurs the line between human and machine, and it's something to seriously chew on as these theoretical upgrades edge closer and closer to reality. Thanks for joining me on this explainer. I really hope it expanded your mind, even if we had to completely break Kevin to do it. Keep asking questions, and I'll catch you on the next one.